Hi everyone, welcome in the second video of the basic 2D limit equilibrium stability analysis. If you are interested in the first video, I would recommend to go to the channel and then watch the first video. So in this video here, I will go and develop the model, define the boundary conditions and the material property and everything, and then I will show the most important feature inside slide 2 and show the results in the most effective and efficient way. So the first step, as usual, we're gonna start with defining the external boundary of our model by clicking on this icon here and then click on T, then click on enter, then paste the coordinates of X and Y, then click OK. To close the boundary, type C, then enter. After we define the external boundary, we need to define the material property. We go to the define material, and in this case we have only one material. I call it soil 1. I used constitutive model, more column, very basic, elastic, perfectly plastic model. We need only two parameters, cohesion and friction angle, for this model, and also unit weight. I defined all of that here, then click OK. The material is already assigned to the model and takes the color, the same color as we defined it here. If you want to change the color, you can change it from here. You can also add hatch, for example, if you want to add hatch. If you don't, then you can just ignore the hatch. You can also control the color of the hatch. We're just gonna keep it as it is for now, yellow. Once we define the material property, now we can define the search method or the method of limit equilibrium. There are almost 10 methods. In this case, I'm gonna use vertical slices and Morgenstern Price method. This method is really advanced method and the most precise method from all of them, because it's considering the shear stress and moment equilibrium. So it takes into account the moment, not only the forces. Click OK. So we define our method. Now we're gonna define the surface or the slip surface. We have here circular and auto refine search. Let's keep it as it is and run it for this scenario. And the next step is define our search, focus search. So in this video here, I'm showing only two search. The limit is only one limit completely. You can use second set of search like this, and you can define where it will start. The slip surface, it will start from here, and where it will end. So it's gonna start from here to here, and then click done. The direction of slip surface, you can define it from general. As you can see, the slip surface or the failure direction is going from right to left. Okay, by going to settings, then general, you can see the direction of the slip surface. So it depends on our geometry. If your geometry is different, has different shape, then you may need to change the failure direction. And that's it. Now we can run the analysis. It may take few seconds. We only have very simple case and one method. Analysis is done. Now we click on this icon, interpret, to see the results. We have factor of safety 1.138. We can reduce the significant digit after the decimal by going to not here, by going to legend option and reduce it from here. We can make this number bigger by going to display option, fonts, and click here, and now we have bigger. We can control the slip surface color and thickness by going to general and change it to 3 and change this to red. So now we have this format. You can also see the property viewer. Here I'm showing the friction angle. Since we have only one material, so the friction angle is a homogeneous model with everywhere the friction angle is equal to 30 centimeters. But once we have different property or different material or maybe different analysis, for example, this is deterministic. If we have probabilistic, we will see the variation of friction angle both in X and Y. I will show you that later in next videos. So let's close this, close the results, and let's create another scenario here by right click on the group. So we have group and scenarios. I want to add scenarios under this group number 1. So I add a scenario here. Let's call it Spencer. And let's add another scenario. Save it first. Add another scenario. Duplicate and call this GLE, which is already analyzed in the first group. I'm just gonna ignore the group and just gonna focus on this scenario. So this one I'm gonna use Spencer instead of GLE, and this one I'm gonna keep it as it is GLE. Okay, and let's add another scenario or another duplicate the group, and here what I'm gonna do, I'm gonna just add a filter for the surface. Actually, let's change, yes, in this second group I'm just gonna change the surface type to non-circular, which is most of the case gives me the most critical slip surface, which is correspond to the minimum factor of safety. And I'm gonna choose path search, so it's non-circular path search, and same thing for here. So now we have first, we can name it actually, so this is, I'm gonna name it circular surface, and this is non-circular. So here we have circular slip surface, we have non-circular slip surface, and both groups it's gonna use two different methods. Okay, let's run this and see the results. This may take few seconds as well. The analysis is completed. Let's see the results. So the first case, let's make this bigger. I'm just increasing the text of the factor of safety just to see it better. As I mentioned before, we're just gonna focus now on the scenarios and see the factor of safety. So in the first scenario we have circular slip surface, looks like that, and we have 1.13. And with non-circular, using search path search method, we have a little bit higher factor of safety. And then so this is from Spencer, this is from GLE. If we compare the GLE with GLE, we have higher factor of safety using the non-circular, which makes sense because you see the slip surface is going deeper, and the weight of each slice is here it's getting higher than this one, and that's why we have higher factor of safety. So we have more resistance using this type of search or a slip surface than this one. Okay, let's add more scenarios and see, compare the response or the difference. Duplicate the groups. In this group here, I'm gonna use non-circular. But what I'm gonna change here is the surface type to Kogo search, same as here this one, Kogo, and rerun the analysis. This is already have been solved, so we're gonna only now solve these two scenarios. See the results by clicking on this icon. Let's make this bigger. So now let's compare circular with non-circular using Kogo search. You can see we are getting a little bit, just a little bit lower factor of safety with non-circular using Kogo search. The shape of the slip surface almost looks identical. And for GLE we got 1.27, 1.127. So non-circular using Kogo search is lower. With similar, almost similar shape of slip surface. So the path search giving higher factor of safety because the shape of the slip surface is deeper now. That's why we're getting higher. We can add another scenario. Let's go back to the model window. If you want to add layers or if you want to modify this model, you can just go to this icon and you can, not this one, actually this one, add material boundary, and you can just add any material you want. You can notice that within the group, if you do anything within one scenario, it will automatically be added to the second scenario. For example, if I want to define another material, call it Soil2, and this one will has, for example, 25 friction angle, 0 cohesion, and 18 or 20 unit weight, 20 kilonewton per cubic meter. Let's call it Slide2. If I assign it here, it will not be assigned to the second scenario, but the boundary will be there because we are working under one group. So you can keep this as it is, or you can assign whatever you want here. So changing the geometry, for example, if I change the geometry, this one to here, it will automatically be changed to the scenario here. If you want to change the geometry and keep the other scenarios, then you need to create groups. This, you can see the group doesn't change the geometry because I was working on group number 4. But any scenarios under this group number 4, it will automatically take the shape from the master scenario, which is group number 4. Okay, let's delete that for now and go back to interpret window. it asked me to run it again. That's fine, we can run it. It's gonna take a few seconds. So I'm just gonna take this scenario and just showing some feature of slide 2. For example, if you want to lock the window, the zoom in window for all scenarios, for example, if I move here to here, you will see the location of the model is changing. It was here at the starting at the 00, now it's jumping all over the place. If I want to lock the screen, you can basically just click on lock zoom, and then if I move it to here, then all the other scenarios will take the same exact zoom, because I like the zoom. For example, here I like the zoom, so it will be all exactly at the same zoom from the screen. Okay, so this is one feature. The second feature, if you want to show the factor of safety for both methods, you can just click on this icon here and show it. In this scenario, we are using only one single method, GLE. But if you are using, for example, 2 or 3 different methods, you can show all of them using this feature. Okay. If you want to show the material property for the model you are using, you can just click on this icon and you can show all the property. If you want to edit this property, you can right click on it, edit the table, and you can choose which value you want to show, which value you don't want to show, or which property name. For example, I'm not interested in Arrow for now, since the model is dry. I can just hide it like this by unselect it from here, then click OK, and you will see Arrow disappeared from the table. If you want to make or add any notes within the model or outside the model, you can click on the text box here and just write whatever you want. Click OK, it will be here. You can control the size from a table, font. You can control the color, and you can even move it to anywhere you like. You can add another one here. You can actually add different values here, and you can have everything. You can change it like this. You can control it, of course. I can change the text size. I can choose whatever I want to show on this table by going to edit text. If I don't want anything, I just basically delete it. Okay, I don't want it for now. If you want any information from any slides, you can see it also from here. All the information. If you want to show all of them at once, you can click here and export the data to Excel. You can show all these slices information in one single Excel sheet. If you want to add some dimensions, for example, if I want to know the slope of this model, I can just go this icon, dimension ratio, and then just double click here. I can make it bigger. Now I have the slope. If I want to add dimension, I can click here. It will add dimension. I can control the size of it similarly of what we did before. I can control the decimal as well. And yeah, so this is for today on this video. I hope you like it. Please don't forget to like and subscribe, and please let me know in the comments what else you want to know about this software and what else you are interested in. Another thing actually I forgot to show, now I remember. As you know, the way that limit equilibrium works, it will iterate of multiple different scenarios and choose the most critical slip surface that gives the minimum factor of safety. But what if someone interested to show all the slip surfaces in our model? You can go to this icon and show all the surfaces, and it will give you this contour or color map legend with showing all the slip surfaces, but the most critical one is this one, which gives the minimum factor of safety. You can filter out, we have a lot of surfaces here, we can filter them out by going to this icon here, and we can specifically ask to show specific surfaces that goes from to factor of safety values. We can change that one, and now it's difficult to see because the color of the map or the color of the material is equal or same as the color map here, but we can turn this off, show everything, and now we can see all the slip surfaces with the color map. I hope you like this video, and thank you so much for watching. Bye.